Hello everybody and welcome to this Easy 11 Plus live lesson on percentage changes. As always, the worksheet is in the video description, which is down here on YouTube and up here on Facebook. Please like, subscribe and click the bell button. If you've subscribed before but haven't clicked the bell button before, please click it now. It's wonderful to see you, whether you're watching on YouTube, whether you're watching on Facebook in the Independent School 11 Plus group, in the 11 Plus Journey, or the Cadwallader Quest's creative writing group. It's really fantastic to see you for a bit of maths today. A new project in this channel, I'm publishing lots of Easy 11 Plus short videos on various topics. Every video has still got a worksheet in the video description, and what these videos do is they take you through a particular topic in normally about 10 minutes, rather than the rather longer lessons that we do live every Tuesday evening at 6 o'clock. Somebody wrote in the comments that they're really nervous before this lesson. Don't worry, however nervous you are, I'm far more nervous every Tuesday. Right, okay, let's get started and let's hope that the screen sharing is working this week. It is. Fantastic. So this is the first question that you can see here in the worksheet. Let's have a look at it. And this is a really typical kind of fairly simple percentage change question, which will enable us to get a bit warmed up with the topic. So what do we know? We know that there were 1,120 students. Oh, I don't want to exit full screen. Go away, notification. 1,120 students at Rosewood High School last year. This year there are 20% more students. Now, I'm going to assume for this lesson that you know what percentages are and that you have a good basic knowledge of how to switch between percentages and decimals. If that's something that you're not so confident with, I'm going to be doing a short video in the coming weeks, which will possibly sooner, which will explain that. But I'm not going to go through everything from first principles in this lesson because we don't really have time. So you should know that 20% more students means 20 extra students for every 100 students that are already there. And that's what percent means. It means per 100. People are firing out answers in the comments already. Right, okay, so one simple way that you can approach this, which you may well have done at school, is along these lines. So you say 20% means 20 out of 100. And we want to find 20% of 1,120. Now, if there's one thing to remember from today's lesson, if you forget everything else, it's this. That of, in English, means times in maths. Simple, but so important. So 20 out of 100, 20% of 1,120. And because, as I've explained in another lesson recently, any number is itself over 1, because if you divide something into one bit, you don't change the amount. So we've got 20 over 100 times 1,120 over 1. Now, cancelling. How good are you at cancelling? Remember, we can cancel zeros vertically. So we're dividing the top and the bottom by 10, but also when you're multiplying fractions, and only when you're multiplying fractions, you can also cancel zeros diagonally, like this. So suddenly, this is very simple. 2 over 1 times 112 over 1. And remember, when we're multiplying fractions, we multiply the top and multiply the bottom. Multiply the top, we have 224 over 1, which equals 224. And that's our answer. No, it isn't. Careful. Because we need to find the total number of students this year, not the number of extra students. So what we need to do, very simply, we need to add it on. We had 1, 1, 2, 0. We're going to add 2, 2, 4. Oh, not very well lined up. Never mind. 4, 4, 3, 1. And that's our answer, 1,344. And I'm pretty sure that's the right answer, and everybody in the comments seems to agree. Now, this method works absolutely fine, and this is probably the method that you've been shown at school. But what I want to do in this session, I want to show you a slightly different method for solving these problems, which is quite often faster, but it has one real benefit, which is you can use it every time for any question, however complex, that deals with percentage change, and it will always spit out the right answer, even if the fractions would be horribly difficult. And the method I'm going to show you works like this. So pay attention. If you don't understand everything first time, you can rewind the video, or you can come back to the video later and rewind as many times as you like. So let's think about it like this. This year there are 20% more students. Last year there were 1,120 students. So that's the whole number of students that there were last year. And how do we, in percentage terms, describe the whole number? Well, we call it 100%. 1,120 students was 100%. Now that's probably really obvious to you, but I'm saying the obvious things because they'll stack up together and make things clear. So, we had 100% and we're going to add 20% more. What's 100% plus 20%? Well, of course, it's 120%, obviously. Now, I said at the beginning, I'm going to assume that you know how to change between percentages and decimals. Now, 120% is 1.2. Why is it 1.2? 100% is the whole of something we call 1. And 20% is 2/10 of something, which is 0.2. So 120% is 1.2. So we need 120% of 1,120, which we can rewrite as 1.2 times 1,120, because 120% is 1.2, of is times, and 1,120 is 1,120. And this means we can set up a multiplication which looks like this. 1120 times 1.2. Remember that when you multiply, you do not line up the decimal points. That's when you're adding or subtracting. When you're multiplying, you don't do that. You just line up the end of each number with the right-hand side of your multiplication here. So we got 1120 times 1.2, and of course you know how to do this. 2 times 0 is 0, 2 times 2 is 4, 2 times 1 is 2, and 2 times 1 is 2. And then what do we have to do when we start the second line of a multiplication? Of course we have to start with a 0. And then we do 1 times 0 is 0, 1 times 2 is 2, 1 times 1 is 1, and 1 times 1 is 1. And then we add it all together. 0, 4, 4, 3, 1. So the answer is 13,440. Or is it? No, we've forgotten something. We have forgotten that there is a decimal point up here. Now, you may have been taught this in various different ways. I'm going to show you a really simple method for placing the decimal point in the solution to a long multiplication, which is this. You go up to the top of the question here, and you say, in total, how many digits come after decimal points? Now here, in this first row, there are no digits after decimal points. And here in this row, there is 1 digit after a decimal point. So that means that we need to go to the answer and pull our decimal point 1 place to the left. So it goes here. 1344.0, which of course is 1344, because 0.0 does not change the value of a number. Now you may be looking at this method and saying, this looks more complicated than the first method above, than this method that we've looked at here. But that's because we did all this stuff here. Now, when you're comfortable with percentages and with this method, you don't need to write 100% plus 20% equals 120% equals 1.2, because you'll know that. And you won't need to write that 120% is the same as 1.2, because you'll know that. So this stuff here, when you're actually doing an exam, when you're comfortable with this method, and in the meantime, by all means write this stuff out, but when you're comfortable with the method, you don't have to write this. You can just go straight in and write 1120 times 1.2, solve it and get the answer. And the reason this method is great is that even if you had to add on 23.2% of students, all you'd have to do is plug the numbers into this method and out the answer pops. It's really important that you're good at long multiplication, and being good at long multiplication means being really fast with your times tables. So if you aren't, practice them and practice your multiplication. But this method just works, and that's why I really like it, and it's why I like it more than the method at the top, this method here, which works absolutely fine when you've got simple numbers like 20%, but becomes really complicated and awkward when you've got more difficult percentages to work with. So choose the method that's best for the question, but if you want one method that will always work and you just want to focus on that, then learn this method here, which is my favorite. And it's also useful because when we get to reversing percentage change later on, this is really important. Or at least the understanding behind it's important. Right, let's push on. I'm just going to have a quick look at the comments now to make sure that nobody's saying that they're terribly confused. Someone says they're buffering. We've had this before. If it's buffering, the problem is with your computer and your internet, I'm afraid. However, don't worry, because you can come back and watch the video later when it's not being broadcast live, and if you just watch it on YouTube as a video, I think you'll find that the buffering is not a problem. Someone says, Malek very thoughtfully says, I'd use the first method because it is easier, there's little amount of time in the 11 plus exam. Well, I hope I've answered that. The second method, if you can get straight to writing 1120 times 1.2 and just solve it, if you know that's what you need to do straight away, then it's super quick. And the other thing is, if you've got complicated numbers, so not just 20%, doing the fractions method will take you a long time because you have to do lots of side calculations, whereas this method gets you straight there. So if you know this method and you understand it, I personally don't agree with you that the first method is easier. But having said that, you should use whatever method you find easiest. And to that extent, I definitely agree with you. Arjun Mayer says, can we use different methods? Yes. The point of maths is to, well, point of maths, that's a big question, but the point of 11 plus maths is to find the answer using a valid method. There are many, many valid methods. Your teachers will show you other methods. Don't go into school and say, you're teaching it wrong because Robert Lomax said to use this method instead. No, this is my preferred way of doing it, which I think will be useful for you. I am not saying that other methods are necessarily less good, that they're wrong. It's a matter of personal preference of what you're comfortable with. Take my advice if you want to, and if you don't want to, I will never know. The price of a washing machine has been reduced by 28%. So see here, we've already got a slightly more difficult percentage to work with. The old price was £350. What is the new price? So for this question, I am just going to show you how to do it using my method that I've shown you. But there are many other ways that you could do it. The price has been reduced, so that means we're going to have a smaller amount by 28%. Now, 28%, if we take 28% away from 100%, that's a horrible zero, minus 28% equals, you can do this without doing a subtraction calculation, equals 72%, of course, because take away 20 gets us to 80, take away 8 gets us to 72. Okay, now 72%, of course, 100% is 1, 72%, as you all know, is 0.72. If you don't know that, you need to do a bit of practice on converting percentages and decimals. There's no shame in not knowing, but there is shame in not knowing and then not doing something about it. So if that isn't obvious to you, study this topic. I will do a video on it at some point soon. Equals 0.72. Now, the old price was £350, so we need to find 0.72 of, and by now you know that of is times, 350. Now this is all the working out that, as I've explained, once you're comfortable with this method, you will do all this in your brilliant, wonderful, magnificent head. You don't have to, but in an exam, there's nothing wrong with saving time that way. If you can reliably know that 100 minus 28 is, of course, 72, you can skip this. Right, so what you're really going to be doing in an exam is writing 350, I shouldn't work on the right-hand side of the screen because I accidentally scroll with my finger. Anyway, never mind. 350 times 0.72. 0.72. And this is it. This is all the working that you're going to need in a test. 2 times 0 is 0. 2 times 5 is 10, so we carry the 1. 2 times 3 is 6, plus 1 is 7. Next line, of course, we start with a 0. Never forget that, or your answers will be very, very wrong. 7 times 0 is 0. 7 times 5 is 35. 7 times 3 is 21, plus 3 is 24. Okay, and then we add it all up. 0, 0. This is 12, so we carry the 1. So that becomes 5, 2. 25200. Now, remember the method I showed you. We're asking ourselves, how many digits are there in total after decimal points in these two rows up here? In the first row, there are none. In the second row, there are 1, 2 digits after decimal points. So we need to go into the answer and count 1, 2 places from the right, and we put the decimal point here. So it's 252.00. We're dealing with price. There are no pence here, so you don't need to write and 0 pence. The answer is just £252. Do not forget the units. And 0 pence that we don't need to write. And that's it. It's simple. So all this stuff over here, you can just ignore once you're comfortable. Your working in an exam can just look like this. Now, some people very, very sensibly said after the last question, wouldn't the first method be simpler? Well, I think now you're seeing a question where we're dealing with 28%. By the time you found 28% of 350 and then subtracted that number, I'm pretty sure you're going to have a method that takes longer than just doing this simple multiplication here, which gives us the answer. It's a matter of opinion. That's mine. You may have yours. On to the next. I'm making a real effort not to spend too long today because that is my abiding sin. Okay, 32 Barking Lane is for sale. It was advertised for £230,000 because houses cost really absurd sums of money, especially if they're nice little detached houses like this. Although it's not a very colourful house, I'm not sure I want it. Anyway, it was advertised for £230,000, but this asking price is now being reduced by 15%. Okay, so there's a lot of wordiness in here. What are we saying? We're saying it was advertised for that. So in other words, this was its price before, but now this asking price has now been reduced by blah, blah, lots of words. You don't need to know what an asking price is. Just pay attention to the key maths wording. It has been reduced by 50%, and you need to know what the new asking price is. This is just like the last question that we did. So I'm now going to assume that you can do those first stages in your head. So what does it feel like in my head? Well, you don't want to know, but anyway, it's been reduced by 15%. That means we need to find 85%. You can do 100 minus 15. So we need to find 85%. And even in an exam, I might just write a quick note here. So we need 85%. And in an exam, I would be doing all this underlining and note-taking, by the way, because it really helps you to focus on the question and not make bad mistakes. So for example, I've circled new. We need the new asking price, not the, that's important, that kind of thing. Okay, 85%, and we know that's 0.85. So all I'm going to write for working in my exam, I am going to write 230,000 times 0.85. Okay, a lot of zeros there, but it isn't complicated. 5 times 0 is 0, 5 times 0 is 0, 5 times 0 is 0, 5 times 0 is 3, only joking, it's still 0. 5 times 3 is 15, 5 times 2 is 10. Totally afraid that working this fast I'm going to make some stupid mistake, but you can laugh when it happens. Right, next line we start with 0, 8 times 0 is 0, we're going to have same zeros but one more place. Okay, 8 times 3 is 24, of course, you know your times tables. 8 times 2 is 16, plus 2 is 18. And then we take this enormous scree of numbers and we add them together, and we hope with our fingers crossed that I haven't made a mistake, which we're talking and doing maths is very possible. Okay, so again, how many numbers after decimal points at the top? There are 2 here, 2 in the second line, none in the first line. So we count back 2 places and put the decimal point. So we find that the house is now on sale for 95500. Is that the answer? Yes, it is, if you want to lose a mark, because you should never forget the units. I said there was only one thing to remember from today, which was that of is times. There are two things. Never forget the units. It's so, 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 so important. Congratulations to Ghost PG3D. Very, very swish name there, who has got this right 1, 2, 3, 4, 5, 6, 7, 8 times according to their post. Okay, super. So it's really simple if you use this method, and when you've got big numbers, awkward decimals, it's a really, really good way of getting the answer, so long as your long multiplication is good and your times tables are reliable and you don't make silly mistakes. If there's one big problem with a method like this, in my opinion, is that when you've got a calculation like this, there are a lot of numbers, and one mistake in one place will make a mess of your answer. So you do need to be careful. So I strongly advise against doing long multiplication while live streaming, because that way you will probably make mistakes. Right. I shouldn't make jokes. It shouldn't be allowed. Anyway, onwards. That was simple. We've done that a couple of times. You probably understand that really well now. So let's go on to something that hopefully you understand a fraction less well, because if you understand it perfectly, why are you watching me? 33 Barking Lane is also for sale, and its asking price has also been reduced by 15%. Okay, fair enough. Similar situation, its new price is 166,600. What was its original price? Okay, so we've decreased by 15%, so we need to increase this by 15%, right? So we know that increasing by 15% is times by 1.15, so we're going to say 166,600 times 1.15, and then we're going to say 5 times 0 is 0, 5 times... Stop! Because this method is one of the most common mistakes in an 11 plus maths exam, and it is very, very wrong. Right, now the question is, why is this method wrong? So to show you why it's wrong, I'm going to take a really, really simple example. So let's imagine that you have 10 pounds. Let's stick with money because it makes it easier to imagine what's going on. You've got 10 pounds, okay? And we reduce this amount by 10%. So what have you got? Well, no surprise, you've then got 9 pounds. Okay. Let's say that we want to increase this by 10% again. So what is 10% of 9 pounds? Well, £9, 900 pence, so 10% is 90 pence. But £9 plus 90p is £9.90, not £10. You cannot reverse a percentage change if you've taken off 10% just by adding 10% onto the new number. Why not? Well, it's really, really simple. 10% of £10 is a different amount to 10% of £9. You can't do it. It doesn't work. The correct answer will not fall out. So that method is not going to work for us, and therefore this is all wrong. I'm getting better at rubbing out. You may have noticed if you've been following these lessons. Very proud of my IT skills. Yeah, and the audio hasn't failed today, so everything is going right. Now I'm going to make some massive mistake. It's inevitable, because everything can't go right for so long. Okay, hello to FF. Hi to you as well. Design with Elim says speak louder. An alternative suggestion, turn up your volume. That might be the best thing. If I mess with the volume now, then it'll be inconsistent through the video and nobody will be happy. Okay. So, pushing on. So we have this question, we cannot do it that way. Now let's think about it. Originally, it had a price. We do not know that price, so let's call it something. Let's call it P. And you might be thinking, oh no, algebra. No, I'm not going to make you do algebra. Its asking price, which we don't know, we're going to call it P, has been reduced by 15%, and its new price is £166,600. So I'm going to draw a diagram, and this diagram is the diagram to remember for problems like this. If you can remember the diagram I'm about to show you, you will always be able to solve these questions. This property started with its price that we're calling P, and it ended up at this price, which is £1,666,600. I'm not always going to use the pound sign for my working, but let's put it here. Now, how did we get from P to this? And this is where the technique that I showed you in the first question really comes into its own. Well, to get from P to this, we reduced the price by 15%. Don't think of that as minus 15%, because we can't minus and add. Think of it as times 0.85, because if you remember, when you reduce by 15%, that means you're finding 85% of the original price, and of is times, and 85% is 0.85. Put all those things together, P was times by 0.85 to get to this. But we don't know P, we know this. So we need to get back from this price to P. Now, if going this way we times by 0.85, we need to reverse that. How do you reverse a multiplication? Well, if you've added something on, you reverse by subtracting it. If you've multiplied by something, you reverse by dividing. And so to get back from the second number to P, we need to divide by 0.85. And that's it. It's as simple as that. That's what you have to do. If you are comfortable with saying reduced by 15% means times by 0.85, and if you know this diagram here and you understand it, then you can always answer a question like this. But you might be saying, fine, that's the method, but how do we apply it? So we need to do 1,666,600. I'm going to miss the units pounds out now because we're into the working. Divided by 0.85. Now, if I try to do something like this, you've got something really fiddly and awkward, and you've got a decimal and so on. So I wouldn't start off by doing it that way. I would remember something else, that another way of showing a division, and if you've watched my video, my short video on converting between fractions and decimals, you'll be very familiar with this. If you haven't, I suggest you look it up. It might be useful. It's very short. It's about 10 minutes. Anyway, the divided by is also the fraction bar, or the vinculum. Fraction bar will do fine. Divided by 0.85. Right, I'm going to speed on a little bit here. So we don't want it to be divided by something, point something. We want a nice whole number. How do we make whole numbers? We times 0.85 by 100 to give us 85. And of course, to keep a fraction with the same overall value, we have to times the top by the same amount as the bottom. Does that make sense? I think it does. 3 over 1 is the same as 30 divided by 10. They both equal 3. So we need to, oopsie daisies, first disaster today, not a very big one. So we're going to write the top number, 600, with 2 more zeros after it. Now we've got a horrendously big number here, but what can we do with it? So we've got this division here. Now we could write out a division, 1,666,000 divided by 85. But it's a bit tricky, they're very big numbers. So when you've got a fraction, you can of course simplify it. I'm saying so too many times, never mind. When you've got one number that ends with 0 and one number that ends in 5, what common factor do they have? You probably know that term. It means what number goes into both of them as a nice clean multiplication. And of course the answer where one ends in 5, one ends in 0 is 5. So 5 goes into 85 17 times because it goes into 80 16 times, and there's one more. Quite easy to do in your head, that I think. If not, you can always do 85 divided by 5 quickly. Bit trickier is to say, what is 1,666,000 divided by 5? I think it's absolutely fine to do a quick division over here. So 1, 6, 6, 6, that's a horrible sixes, sorry. 0, 0, 0, 0 divided by 5. Right, let's not get this one wrong. 5 goes into 16 3 times, remainder 1 goes 3 times, remainder 1 goes 3 times, remainder 1 goes 2 times exactly. There we are. Not too bad. So we've got 3, 3, 3, 2, 0, 0, 0 divided by 17. Now these are pretty fiddly numbers, I have to say, but you might come across this kind of thing in an 11 plus exam. You're quite likely to be luckier and have some slightly simpler numbers to work with. But come on, it isn't too hard. It's just about working through systematically. But it's this kind of question which really tests how good your paper calculation methods are. Can you do divisions comfortably? Can you see quickly how many 5s go into 85? Can you do this sort of stuff over here? Really work on these techniques if you aren't very comfortable with them. They will help you a lot and save you a lot of time. Right, now we have to do, of course, we can't escape it any longer, a long division. But you can do long division, it's not so bad. There are lots of methods for this. This is mine. 3, 3, 3, 2, 0, 0, 0. In my short videos, I just fast forward through these bits. Because this is live, I can't do that. How many times does 17 go to 33? It goes once. Okay. 1 times 17 is 17, subtract them and we get 16, I hope I don't make a mistake in here. Then we carry down the 3, draw an arrow there just to make it clear what I'm doing. How many times does 17 go to 163? Well, 17 times 10 is 170, so it's going to be 9 times because it's just below that. What's 9 times 17? 10 times 17 is 170. Take away 17 from 170, we get to 160, 153. I know I'm talking fast, but it's because you don't want to see me slowly doing this whole thing. It will just kill you with boredom. Then we carry down the 2, 102. How many times does 17 go into 102? Well, if 17 times 10 is 170, then 17 times 5 must be half that, so 85. 17 times 5 is 85. Add 17 to that, and we get 102. So it goes in 6 times exactly. And we're there. 196,000. And so our answer is 196,000, what's? We're talking about money, pounds. And there we are. That's it. Now, I'm not going to tell you that's incredibly simple, because there were a lot of stages there. There's some awkward paper calculation, which I know is annoying to do. But the method is surprisingly simple. Let's just revise it very quickly. So, I need to find a word instead of so. Maybe you make some suggestions. It's better than looking here, we can see that there was an original price, P. We don't know what that price is. We know that that price was reduced by 15%, which means it was times by 0.85 to get our new price, which is 166,600. To get back from this price, which we know, to the original price, we have to reverse that multiplication, which means we divide by 0.85. So we know that the answer is going to come from doing 166,600 divided by 0.85. And that is the thing to remember. This box here, I'll do another box around the box just because it's so important. If you understand that box, if you can use it in any reverse percentage change problem, and you will find the answer as long as you don't make a silly mistake in all this mind-numbingly boring calculation. How do we do the mind-numbingly boring calculation without numbing our mind, whatever? We write 166,600 divided by 0.85. You don't need to worry about this line here. I just did that to show you. You don't need to write that out. So write out the fraction here. Then we want to make the number on the bottom a whole number. So in this case, that means moving the decimal point 2 places, which means timesing by 100. Ananth, if the screen is blurry, it's probably your computer, but don't worry, you can always come back and watch it again if you love my lessons that much. I love having you. So we got over 85. I'm saying again, I should say so. The top number we also have to times by 100 to keep them the same. So now we've got 1666 and zillions of zeros over 85. We want to simplify this. We can see that they have a common factor of 5. So we can divide them both by 5 in plain English. And we did a little bit of working out over here to get that. And that led us to this here. Then hard to cancel that further. So then we remember that the fraction bar here means divide. Of course, that's the whole principle we're working on. So we just do the division and we put it in here. This is my long division method. There are lots of long division methods. If you've been taught a different one, use the one you've been taught. I'm not saying mine's better. Mine was taught to me, 74 years ago when I was your age. That'll do for that. Okay. Let's push onwards, but I think it's a really good time to have a break and give your poor suffering minds a rest. So let's take a moment out for the that was me trying to take the time for the tip of the week introduction to cough, but then remembering that the microphone still works during that graphic. Oh well. I haven't got coronavirus, I think. So the tip of the week for today is that when you're studying, you're probably practicing lots of questions and you're probably learning lots of techniques. But what I want to point out is that the other really important thing to learn is systems for doing different kinds of question. So for example, with the questions we're looking at today, you may know lots of different techniques for doing percentage change and reversing percentage change. But do you have a really good system that you can just apply whenever you see a question like this, knowing that the answer will come out? Well, today I've been trying to teach you my system for these questions. But this is something that applies across your 11 plus work. When you're doing multiple choice comprehension, do you have a really good system for eliminating the options, for checking the passage consistently, and then for choosing between the things that are left? Because having a really good logical system is worth at least as much as having really good reading skills and understanding the text. When you're writing a story, do you have a really good system for analysing the question, coming up with ideas, writing a simple plan and putting it together? These are all systems. So as you revise, don't just think about the knowledge and about practice, think about the systems, those repeatable methods that you can use again and again, that you can apply whenever you see a relevant type of question. Because coming up with good systems is, in my opinion, about 50% of what good 11 plus preparation involves. Okay, let's go back to the lesson. We're coming towards the end of these questions. So, a jar of Joggleberry jam, I don't know what a Joggleberry is, but I'm sure it's delicious, would have cost £1.68 2 weeks ago when it was offered for sale at a 40% discount. Whoa, lots of words in there. Lots of people say, by the way, let's practice word questions. I don't really think word questions are a separate category of maths problem. I think word questions is just what happen when you take maths and stick words around them. But the maths is still there. And what you need to get used to is just looking at a question and saying, don't worry too much about the clutter, read it, make sure that nothing changes anything, but just learn to focus on the essentials and don't be scared by the words. So what do we really know here? We know that something would have cost £1.68. We can just get rid of would have. So it cost £1.68 2 weeks ago when it was offered for sale at 40% discount. So it was discounted to this price. This was what it cost, but the original price would have been 40% more. So the price was times by 0.6 to give £1.68. How do we know that? 40% discount means it was actually costing 60% of its original price, and 60% is times 0.6. When you start off, you'll probably write out all those stages of working. What I'm showing you here is what you might write when you're comfortable with the method, and you can skip a bit of that. This week, jars are instead being sold at a 15% discount. But a 15% discount from what? We don't know, because we don't know what the normal headline price of this jam should be. How much would a jar cost this week? So we need to find how much it would cost this week, but there's lots else that we need to know before we can get to this. First of all, we need to find out what the original price would be if it wasn't offered for sale for £1.68. So you can break up your working with headers like this. It makes things really clear for the marker, but also for you. It means you know what you're doing at each stage. First thing we're going to do is find the original price. I probably would actually write this if I was doing the working out for this question. So the original price, so remember, original price, P, it was times by 0.6 to give £1.68. And so to reverse that, we have to divide by 0.6. Okay? Fairly simple. So it would have cost £1. It cost £1.68 when it was offered sale at 40% discount. We need to find the original price. So how do we reverse this? I just have this horrible panic that I'm making some mistake and talking rubbish that cannot be changed, but hopefully I'm not. So let's look at the method again. 1.68 divided by 0.6. Okay, we want 168 over something, so it equals 168 divided by, we times that by 100, haven't we? So this needs to be divided by 60. Okay, 168 divided by, I'm just having a panic that I'm doing something really stupid, but fingers crossed I'm not. Okay, 168 divided by 60 equals, so 60, 168, they're both divided by 2. It's always simple just to divide things by 2, equals 84 over 30. And these are nice whole numbers, so we can do 42 over, even numbers I mean, sorry, 42 over 15. Okay, and then we need to work that out. 42 divided by 15. Why am I doing it like this? I do not know. I'm having a horrible panicky thought that I've misworded this question, but let's carry on anyway. So 42 divided by 15. Sorry, I'm talking absolute rubbish. 42 and 15. Could both be divided by 3, can't they? Goodness me. 42 divided by 3. Well, what's that? It's 14, isn't it? Because we've got 14, 28, 42 equals 14 over 5. 14 over 5 equals 2 and 4/5 equals £2.80. So the original price was £2.80 before it was discounted by 40%. Okay, but we need to find out how much it would cost this week. This week it's being discounted by 15%. So original price, next heading, this week. Someone's writing Joggleberry zillions of times. So this week, they're being sold at a 15% discount. So this is the easier part, because now we just need to discount this price by 15%. And you remember we've actually done this already. If you discount by 15%, that means you're finding 85%. And I will just note it down as a reminder, equals 0.85. So we need to find 2.80 times 0.85. But I'm not going to do it that way. I'm going to work in pence, because that can be a bit easier. I'm so sorry. I've done something absurd. Why am I dividing? Why am I dividing? I've gone mad. Right. This bit might need to be edited out of the video. Oh well, you've seen it happen. Well, I hope this is proof that anybody can make a complete fool of themselves with 11 plus maths. We need to find 0.85 of £2.80. And what did I say at the start? Of means multiply. Of course it does. So we need to find 2.80, which is 280 pence, we'll stick to pence, times 0.85. I'm dying with embarrassment, but never mind, we'll get there. And you'll have learned by seeing me make a fool of myself. 5 times 0 is 0, 5 times 8 is 40, 5 times 2 is 10, plus 4 is 14. 0 next line, 8 times 0 is 0, 8 times 8 is 64, 8 times 2 is 16, plus 6 is 22. And we can add it together, 0, 0, 8, 3, 2, phew is the right answer. We've got 2 digits after decimal points up here, so we put the decimal place 2 from the right, and so we have our answer, ladies and gentlemen. It's 238 pence, so it's £2.38. Oh goodness me. Right, we got there in the end. Fantastic. Right, I'm going to escape into your questions. One of your questions might be, why on earth are you teaching maths? But I do actually claim to know this stuff. Oh dear. Let's go to the questions. I'm so proud of all the people writing no, wrong, pence, pounds, no point on the right hand side. Yes, you're the people I need to keep me on the path of righteousness. Okay. So your questions will follow very soon, but there's about a minute delay between you writing comments and me seeing them. So I'm going to power on with a question that I have been asked many times recently, which I'm sure some of you are on the verge of. Someone's writing, what is happening with him today? I don't know. How can I speed up my time in maths? Well, there's one thing that I think I've illustrated really clearly in this lesson so far, which is that too much speed can be a problem. And that sometimes it's actually important to work a bit more slowly, pay careful attention to the wording, and get it right rather than rushing through. And actually, if you work steadily and carefully and there aren't big hold-ups in your maths exam working, you'll probably get through to the end just fine. It's those hold-ups that you need to concentrate on. You need to identify those points when you're being slowed down and work out how to address those problems, concentrate on those skills, so until you can work steadily at those things without being slowed down. Another thing that's really important, fast times tables. I've mentioned it before. They will speed up your working a lot when you've got big multiplications, big divisions like this. Your times tables, if they're fast, you'll get through them much more quickly and waste less time. Likewise, your paper calculation techniques, practice them until they're nice and slick and you're not making silly mistakes. Organize things nice and clearly on the page. Even if your writing is a bit messy like mine, try not to let everything get tangled up with everything else. Someone's writing, how do I build speed and accuracy? Someone's written, I think they're trolling me, someone's written, what if you get really confused with the decimal points, like my answer at the end? Take your time and don't rush and think about them, but also just do lots of practice on converting between fractions, decimals and percentages until you're really comfortable with it. I do, as I've mentioned already, I have a video on this channel about converting between fractions and decimals. I'll add something about percentages and fractions and decimals as well. Someone says you should have consecrated. That's deep, but I'm not entirely sure what you mean. How to understand when do I divide, multiply the percentage? I love these questions that read like trolling after this lesson. You multiply when you're finding a percentage of something. You divide basically when you want to reverse a multiplication that's already happened, because dividing is the opposite of multiplying. What do you do if your answer is 238 pence? Will you get it right? If you write pence, so you've clearly got the units, then you might get it right, but it depends. I think there's a decent, it depends on the market. It's better to write in pounds and pence. I'd probably mark that right. Is there any easier way to find percentages off? There may be ways that are easier for you. It depends on what you're confident with. I think the method I showed you at the very start is basically the most common method that's taught, where you do it in 2 stages. You find the percentage and then you subtract it. If you can do it in 1 stage, you might save yourself a bit of effort. Will you do non-verbal on this channel, especially nets? Yes, I will. What topic are we learning next week? I haven't decided yet, but I do notice a lot of people asking for NVR, and that is something I'll bear in mind. We might well do that next week and hopefully not get so much of it wrong. Do you lose a mark if your presentation isn't good? I think this can mean different things. So across 11 plus, if your presentation is really messy so that somebody can't properly read the answer, and they can't see what you actually mean, so in English if they can't read what word you've written, or in maths if they just don't know what you're saying, then you've got a problem. As long as it can be read, and read unambiguously, so the word couldn't be a different word and so on, then you're fine, even if it's a bit messy. With maths, in terms of presentation, it's not just the neatness of the numbers, it's about trying to line things up clearly. So for example, if you're doing algebra, make sure that the equal signs are all in a row. If you've got a table, make sure that things are straight, because otherwise it's really hard to tell what relates to what. Someone says, why is the cover of the video you with a pillow? The second I saw it, I thought I was a sleeping lesson. I was just trying to look like I was hiding from the from percentage change problems. Perhaps I should have hidden from the percentage change problems. Are there any easier methods for long multiplication with decimals? No. If you're going to do a long multiplication, it's going to be a long multiplication. That's how you do it, really. There are other methods, but nothing that I would really regard as easier, but maybe other teachers would have different opinions. Right. Is there anything else? Loads of people asking for verbal reasoning. I've answered that already. I will do verbal reasoning, and I'll do it soon. How do you maths with a percentage over 100? Look back through the video. We had an example of 120%. That means that the old amount was 100%, but you're adding on 20%, so you've got 120% of the original amount, which is a bigger number. 2 is 200% of 1. Can a percentage be over 100? Yes, absolutely. Okay. So what's the difference of £2.38 and 238 pence? Just that £2.38 is a neater way of writing it, and if the question uses pounds, then it's better to give an answer that involves pounds and pence. Just get used to doing that. 238 pence is, of course, correct. If you started saying 238,588, 900, or whatever, I'm talking about not even a number, pence, then is a real question. Why have you used pence? Why haven't you simplified it into pounds and pence? How do you get full marks in your maths exams? Obviously, that's a very broad question, but I think if there's one thing to take from today, two things to take from today. One, as I said in my tip of the week, have really good systems that you can apply. So you're not just doing everything from sort of first principles, but you think, well, here's this question, I can apply this method that I know, and it'll follow through like this. And the other thing is to take your time and take care and beware of the silly mistakes. I don't know anybody who makes silly mistakes in maths. Do you? Right, that's enough questions. I should get my dinner. It's been wonderful to see you this week. Please like and subscribe and click the bell. And I will see you very soon. Goodbye.